We will do supervised and unsupervised learning, gradient descent, and stochastic gradient descent. In other cost functions, we'll do regression analysis, logistic regression. We'll look at overfitting and regularization. We'll look at other forms of regression, like lasso regression, ridge regression, elastic net regression, variance and variance in regression models. So then we'll then look at the coding. So we'll use the Google tool called TensorFlow, and also we'll use a scikit-learn. So we'll then do introduction to TensorFlow. We'll cover the TensorFlow basics for you to be able to do a machine learning. We'll mainly use what is called the Keras API to be able to do machine learning. And then we'll look at the ordinary machine learning models. I wouldn't call it necessarily advanced, but we look at things like k-nearest neighbors, naive Bayes, support vector machines, k-means, decision trees, random forest, gradient boosted regression trees, and ensemble techniques. We'll also look at, then we'll do introduction to deep learning with TensorFlow and Keras API. We'll look at perceptron rule learning, artificial neural networks, activation functions, universal approximation theorem of neural networks, feed-forward neural networks, multi-layer perceptron backpropagation algorithm, residual networks, convolutional neural networks, transfer learning, image recognition, object recognition, and we'll then look at deep learning for sequence-to-sequence models, right? We'll look at recurrent neural networks, gradient vanishing problem, and backpropagation through time. We'll look at gradient recurring units, long short-term memory, bidirectional recurrent neural networks, bidirectional gradient recurring units, bidirectional long short-term memory. We'll then look at the neural machine translation. And then we will we'll then look at the natural language processing. We'll do introduction to NLP, natural language processing. We'll look at deep models for solving machine translation and conversation problems. We'll look at deep structured semantic models of information and retrieval and natural language applications, and deep reinforcement learning models on natural language applications, deep learning for sentiment analysis, speech recognition models used in deep neural networks. So, for example, you learn how things like Amazon Alexa and Google Home work in terms of using speech recognition. Yeah. So that's the syllabus. So therefore, you see, it's impossible to do this in 4 lectures. You actually need about 10 to 12 lectures to be able to cover this content. I had to squeeze things and rush things through because a lot of the work that you guys will be doing is actual practical programming assignments, analyzing data, where we walk you through how to do several analytics, and you then do that on your own. So therefore, it's impossible to do that in 4 lectures. So I'm not a miracle worker, so I'm not. I don't expect you guys to be to miraculously learn this content, but it requires time. That's all. It's a factor of time and practice. Therefore, 4 lectures will never cut it. So it's impossible. Anyway, so let's look at how decisions are made. Right? Are there any questions so far?
Yes, sir. When you say 10 to 12 lectures, I just want to know the duration of each lecture.
We'll be looking at maybe I'll say about 5 hours. 5 hours a lecture, and you don't want to do too much as well, otherwise you end up drowning in these lectures. Right? So you also need time to reflect and digest what you've learned.
Okay, thank you.
So guys, if you've got any questions, just so Google Meets does not give you the ability to raise your hand, right? So that you can actually see that someone has got a question. So therefore, just shoot off and ask the question, right?
So how best can we compensate these 12 hours?
Sorry?
How best can we compensate these 12 hours given the...
I mean 12 days, you mean?
Pardon?
I said you mean 12 days, not 12 hours.
Or 12 days?
Yeah, it's not 12 hours. It can't be 12 hours. I said 12 days.
Hi, Doc.
Yes.
Is it possible, I think, to cater for the 12 days, is it possible maybe to do maybe after hours, after working hours?
So we will look at how we can arrange it. So on this course we have got our tutors as well who will walk you through some of the areas and assist you guys as well. So I've got 5 tutors who assist with these lectures. So I'll introduce them when they are available. So I will introduce them as when they are available as well. So yeah, so we can come to some arrangement and we can work out what works best for you guys. Right, can you see my screen?
Yes, Doc.
Okay. Yes.
Yeah.
Yes, right. We can see it, Doc.
Yeah. Let's talk about, in terms of when we talk about data analytics, data science, machine learning. So let's understand, especially for decision making. Let's understand. We need to drill down into the differences in terms of how decisions are made. Right? When we say data science, what do we mean when we say data analytics? For effective decision making, what do we actually mean by that? So let's look at how decisions are made. Let's look at how decisions are made. So a lot of decisions you find in companies, and especially in the Zimbabwean context, there's a lot of thumb sucking, right? By thumb sucking we mean there isn't any science to making a particular decision. It's just based on there isn't even a rule of thumb. You just come up with some random, decision, right? So that's what we mean by thumb sucking. There isn't any science to just make a particular decision, which is a random decision, which is not based on any data or any science at all. just make that's what we mean by thumbs up. You just make a decision, and then so then then there's the other one called guesstimation or guesstimating. So guesstimating is simply you, for example, you if Arsenal is playing Chelsea, for those football fans, and if they've been drawing in the past 3 games, right? Then you then guesstimate to say, the likelihood, there's a high chance that the next game will become a draw. So guesstimation, you're actually then making a decision within certain boundaries. So that's what we mean by guesstimation. You are using some information, right, that you're using to derive a decision, but it's still guessing because there's no science to it, right? And then gut feeling or instinct is like I woke up on the left side of the bed, so this today I'm you know, making this particular decision because I woke up on the left side of the bed. So gut feeling and instinct is or I dreamt, doing this particular function, and therefore that's what I'm going to do. So it's not based on any science. It's just based on instinct. And then leap of faith. So leap of faith has got nothing to do with religion. So leap of faith, for example, you don't have any prior experience in running an airline business, and then you write a business plan to go to a bank to buy 10 jumbo jets. And then you expect them to take a leap of faith in your idea that you'll be able to make it work. So that's what leap of faith is, right? And okay, let me move on to the next slide. So then there's past experience. So past experience is you're making a decision based on a maze of prior experiences that you've had in the past. Right, so you're making a decision based on past experience, not necessarily on data, but past experiences. Right, and then there are political decisions. Right, so political decisions, I'm sure most of you guys, we know what those are. We've had a lot of experiences of those decisions in Zimbabwe. So I will not give you examples because this is not a political science class. It's you know what political decisions are. So it's any decision that is based on politics, and it's got nothing to do with the data at all, right? Yeah. And then rational decision. So rational decisions are decisions that where you think something through, either based on past experience or whatever criteria you use, right? You then make a decision based on that rationalization. So that's another way of how people make decisions. So when we talk of data analytics and data science and machine learning, we're talking of decisions that are made and inferred from data. So there's no rationalization, there's no guesstimation, there's no thumb sucking, there's no politics involved. Data is the core component of that particular decision. So it's a very different way of making decisions because data does not lie. Data will give you actually a story of what is happening. So this is why it is then important to learn data analytics. Because data analytics is about making decisions that are inferred from data. Are there any questions so far?
We are good.
Yeah. So when we talk of, if we're talking of data, right? So the internet is one place where a lot of data is generated. So let's look at what happens online every 60 seconds in terms of data generation. Right. So if you look at what happens online every 60 seconds, so for example, in 2012, there were 168 emails sent every 60 seconds. And then in 2014, 204 million emails sent every 60 seconds. And then in 2020, they're looking at 1 billion emails sent every 60 seconds, right? And then if we then look at, for example, Facebook posts in 2012, there were 79,361 posts that were sent every 60, Facebook posts that were sent every 60 seconds. In 2014, 3.3 million. In 2020, it's around 20 million Facebook posts every 60 seconds. And then for WhatsApp, in 2012, there were 20 billion messages sent every 60 seconds. In 2014, it was 50 billion messages sent every 60 seconds. And then in 2020, it's 150 billion messages sent every 60 seconds. So you can see. So if I go on to the next slide. So this is the activity that you see happening online in terms of the data exchanges. So this is the exchange of data that's happening online every 60 seconds. Well, one thing you'll find about data, which is very peculiar, right? And it applies to every continent, it applies to every single country and economy, right? So what this picture tells you, right? What you see, this light flickering on and off. So you'll see that there is a one-to-one relationship, right, between how much the GDP of an economy and how much data it generates, right? So the biggest economy is obviously the US, right, the United States of America. And if you look at the US here, you can see there's a lot of data activity that is being generated, right, through the internet, the exchanges of data that are happening on the internet, right? And then you can then look at Europe. It's the same. It's the same thing. You can look at China. It's the same thing, right? Then look at India, right, which is here. It's the same thing. So there's a direct relationship. Of if there are any economists, right? It's something that that hasn't come up yet in economics. There's a direct relationship between how the GDP of an economy and how much data it generates. So we can even take that from a macro level to a micro level. So there's also a relationship between the amount of data that a company generates and the value of that company. So let's look at, for example, the biggest economy, the US, the United States of America. If you look at whatever is traded on the New York Stock Exchange and the different other exchanges in the States, the number one biggest company is Google, right? Google generates more the biggest amount of data, right? Then if you look at Microsoft, the next stock, it generates the most amount of data, right? And then if you look at companies like Tesla, Amazon, and so on, all of those companies generate massive amounts of data, and they are the most valued companies in America, right? Then if we then look at that from an African perspective, we come to Zimbabwe. If we look at the Zimbabwe Stock Exchange, right, the number one performing counters on the Zimbabwe Stock Exchange, we've got Old Mutual. Old Mutual generates a lot of data, right? Then if we look at Econet, Econet generates quite a significant amount of data. Then if we look at even CBZ Holdings, it generates quite a lot of data. So there's a direct relationship between the value of a company and the amount of data it generates, right? Yeah. So that applies on a micro level and on a macro level. So if you look at this map of the data exchange, so if you look at the biggest economy in Africa, it's South Africa. You can actually see, right? Then from South Africa, then followed by Nigeria. And so on and so on and so on. So this actually tells you, it's almost like it's a map of the GDPs of the world, right? But this is just a map of the data exchanges that are happening around the world, right, over the internet. Are there any questions? Yes. Which screen are you on? Yeah, can you see the map? Yeah, oh yeah, probably. Can you see my mouse? No, you can't. I think maybe Google Meet doesn't allow it. But anyway, from the map, right, you can see the US, right? You can see the flickering of the exchanges that are changing color, of the data exchanges that are happening. Yes. Yeah. So from you can see. Yeah. So you can see this picture actually tells you a story, right? So in America, if we look at, for example, for America, right, North America, you see that the US is the biggest economy, right? Then followed by Brazil, right? Can you see this is Brazil? You know where Brazil is, right? Yeah, and then followed from Brazil, followed by Argentina, right? And so on and so on. So you can actually see this gives you a picture of the size of the GDPs of those economies, right? But this is just data exchange showing you a one-to-one mapping to the GDP, right? Yeah. So there's a direct relationship. Yeah. So what that actually means, right, guys, is as long as all of these economies are generating all these huge amounts of data, right, they will always need people to make sense of that data. We'll always need people to make sense of that of that data. Right? Yeah. So you can see Zimbabwe somewhere here, Zimbabwe, right? You can see some activity, a little bit of tiny activity happening there, right? Not much, right? In terms of the from a global point of view, and from an African point of view, there isn't much, yeah. Right? Yeah. So a lot of these things in Zimbabwe, hey, we're the most educated country, hey, that's a lot of nonsense, right? It doesn't translate it to anything, right? So they should just shut up. It doesn't translate it to into being a big economy or anything like that. It's just talk, right? This actually gives you a picture in terms of what's really happening in the world in terms of data. Right. Okay.
Okay, Doc.
Yes.
While least we are still there, I wanted to ask you what can we say about the adoption of machine learning or the use of machine learning especially in Zimbabwe? Since you have been in the industry for so long, what can you say about the adoption, the rate at which enterprise are now focusing on machine learning or are thinking about machine learning in decision making when it comes to Zimbabwe, basically?
Zimbabwe is an interesting country in the fact that you get people who are highly, sort of educated. Zimbabwe's got people who are educated, right? A lot of the CEOs have got some MBA that they've done somewhere, and funny thing is, majority of CEOs come from a chartered accounting background, some kind of account for some reason. But then you find the performance of those companies, the key performance indicators to track the performance of those companies is actually not based on data, it's based on other factors. So there's a lot of thumb sucking, there's a lot of guesstimation, there's a lot of a rationalization or things that actually don't make sense, right? So if you look at even decisions that are made in this country, then none of it is based on analyzing data. It's just based on gut feeling and estimation. So we'll talk about what is called the data analytics maturity model, where we're going to detail, and then that will then give you a full picture of where exactly a lot of these companies are. All right, so moving on so how much data is generated per day, right? So 1,000 kilobytes is 1 megabyte. 1,000 megabytes is 1 gigabyte. 1,000 gigabytes is 1 terabyte. 1,000 terabyte is 1 petabyte. 1,000 petabytes is 1 exabyte, and 1,000 exabytes is 1 zettabyte. So we generate 15 zettabytes now, 50 zettabytes, sorry, of data every day. So this has to be updated. So this is what it looks like from 2008 up to 2020. So 2020 is now on 50 zettabytes of data. So I actually need to change this. Is actually 50 zettabytes. All right, so we generate 50 zettabytes of data every single day. So if you look at from 2008 coming up to 2020, you can see there's an exponential growth of the amount of data that is generated, right? It's an exponential growth, right? So as long as you guys are generating that much amount of data, there's going to be a huge demand for people who analyze their data in the form of data analytics, data scientists, and so on, right? So it means the demand is only going to grow. So if you look at last year, there were probably in the newspapers, if some of you guys saw, there are probably about 50 adverts on where different companies were looking for data analytics, data scientists, machine learning engineers, and things like that. So there are about 50, right? About 50 positions, right? And out of those 50 positions, majority of those were actually filled in. I would say maybe 99% of those were filled in by people from this class, right? From the people that I taught in the various classes at Chiurunge. All right, so let's talk about what you've heard the term big data, but what is it? Well, what is big data, right? Well, what is big data? So big data, we one aspect that we looked at is the volume. We looked at the sheer amount of volume that was generated every 60 seconds and per day. So that's one aspect of it. So we characterize big data by 8 V's that we refer to big data. So one of them is volume. We should look at the sheer amount of volume of data that is being generated. So that's the first V. We look at the volume, which is the amount of data. Right? We looked at 50 zettabytes of data generated every day. And then variety. So variety is got to do with the different structure of data, right? So we've got what we call structured data. So structured data is data which is defined in clear rows and columns, like your spreadsheets, like your databases, right? That's structured data. Then you've got semi-structured data. So semi-structured data is data that is more loosely defined, which is like your tweets, which are defined maybe by a hashtag or a Facebook post, which is defined by a particular link and so on, right? That's your semi-structure. There's some, it's loosely defined, but there's some structure to that particular data. Then you've got unstructured data. So unstructured data is like your YouTube videos where there's no specific defined format to that particular data. So variety talks about the different structures of data. So we've got structured, semi-structured, and unstructured data. So those are the 3 types of data structures that we have, the 3 different varieties of data. And then velocity. So velocity has got to do with the speed at which the data is generated, right? The speed at which data is generated. So we looked at what happens every 60 seconds. So that's an example of the velocity of the data, right? So velocity has got to do with the speed at which data is generated, right? And then we've got, are there any questions on this? Yeah, absolutely, of course. And then we've got a veracity. So veracity has got to do with the authenticity of data. Veracity is about authenticity of data. So we are living in an era of fake news, right? So veracity has got to do with the authenticity of data. How authentic is the data? Is it fake news or is it not fake news, right? So that's what veracity means. So it's got to do with the authenticity of data. And then we've got variability. So variability has got to do with the change of meaning of data over time, right? So variability is the change of meaning of data over time, right? So if you look at, for example, change in meanings over time, for example, if we look at Shona, let's look at maybe Shona, for example. In Shona terms, if 5 years ago, if you said Baba Chibaba, Chibaba meant an old man, right? If you directly translate it to English, Chibaba meant an old man, right? But now Chibaba means something totally different, right? Then if you look at something like 5 years ago, if you said Simbi just meant a piece of iron, right? But now Simbi means something else. But Simbiam Dara, it means something else, right? It doesn't mean the iron of the old man, right? It means something completely different, right? So variability has got to do with change of meaning of data with time. So an example, English, bad means it was turned to mean good, and so on and so on, right? Yeah, so that's variability. Then you've got value. So value has got to do with the value of the data that is being generated, right? Is that data got value, right? That's what we mean by the sixth V, value. Is that data valuable, or is it just gibberish? And then the seventh V is virtualization. So by virtualization, we're looking at the compute and the storage aspect of the data, right? We're looking at the compute and the storage aspect of the data. That's what we mean by virtualization, right? So you guys are using a Gmail, right? Where is it hosted, right? How much storage do you have in that particular in your Gmail or your Google Docs or your different or your Dropbox and so on. It's hosted in the cloud, so it means it's virtualized. And then you now need some kind of compute capability as well to be able to download that data. So you've got virtualization, which looks at the storage and the compute capability of data. So that's a virtualization. Where is it stored, and what compute power do we need to be able to store that data? Right? So that's virtualization. So, and then the other, the last V of the 8 V's is visualization. So visualization is got to do with the summarization of data in pictorial form, because you're dealing with such vast amount of data, right, which is being generated at a fast velocity, and there's different varieties of that data. So it only makes sense that you don't want to suffer from paralysis analysis. So therefore you represent data in forms like dashboards, pie charts, histograms, and so on, to be able to make sense of and keep track of that data, right? So these are the 8 V's. So volume, variety, velocity, veracity, variability, value, virtualization, and visualization. Are there any questions on this?
We are good.
We are good, sir.
All right. So you hear a lot of reference to what they call the data deluge. So the data deluge is just the outpouring or the amount of outpouring of data in the past decade. We just had so much deluge of data that is being generated. And we spoke about virtualization. So part of the challenge of big data obviously is the storage, because you're generating a lot of data. Obviously you need to store it somewhere, right? So storage becomes an issue, and also for you to be able to analyze that vast amount of data, you need large amount of compute capability. Right. So then if you look at the big data ecosystem, so there was a big data ecosystem which was talked about a lot, from in the past decade, which especially starting around 2012 up to about 2016, 17, and then the model changed. So then if you look at the various data sources. The data acquisition was mainly through what we call an ETL process, which is extraction. You extract that data, you transform that data, and then you load it. You load that data into some platform, right? So mainly there was a lot of tools that were used for that, and some of those tools were Scoop, Apache Spark, and Flume. And then the data storage to create the data warehouse was based on Hadoop and using HDFS, and they used tools like HBase and Cassandra for that. And then in terms of the data analytics, this is the era of BI, business intelligence, right? And for that, they used things like Apache Spark, Hive, and Cloudera, Impala. So mainly these tools were centered around a structured query language, where you would extract the data that you want through some form of query of the data to then create the business intelligence, right? And then the reporting and visualization was done by either Excel or Power BI, Tableau, ClickView, ClickSense, or any of those visualization tools. So this is the ecosystem that really dominated the around 2012 to about 2016, 17 there. But that model has since changed. So we now think a lot, especially in machine learning terms, even if we're dealing with vast amounts of data, we think of data as a pipeline, more of, just extracting, transforming, and loading data. We think of it as a pipeline, that you've got different sources of data that you then combine, and that data then flows through a pipeline, like a normal processing manufacturing plant, where you've got a partial processing that happens from within that factory to work on a particular product, right? So this is now the modern concept of thinking of big data analytics, that it's no longer this aspect of just thinking of storing data in a particular storage place. There could be multiple storages that you can think about. This is why we've got what we call a data lake instead of a data warehouse, which is a different paradigm of thinking, because data warehouse deals with structured data only, and a data lake deals with structured, semi-structured, and unstructured data. Right? So different way of looking at analytics, and therefore machine learning has to be able to analyze structured, semi-structured, and unstructured data. Right? So then you then have to look at those three different types of data and how to analyze those different structures of data. So the machine learning pipeline looks something like this. that you've got different data locations, and then you ingest that data, right? And then you've got some kind of data preparation that you do. Normalization, you normalize your data because you want to get rid of anomalies in the data. And then you transform that data to be able to analyze the data, and then you want to validate the data. And then featureization has got to do with selecting variables which lead to the contribution of the performance of the particular model that you're working on. And then you build and train your model, right? And then when you're building and training your model, you do what is called hyperparameter tuning, and then you do automatic model selection, you do model testing and model validation, right? So so if you understand that machine learning is a pipeline, right? So we'll start off with data prep in our exercises. So data prep, normally you use NumPy and Pandas, right? This is why it's important to know NumPy and Pandas, because data prep is done by NumPy and Pandas. Then you build your model, then you deploy your model, right? You build your model, and then you deploy your model. But you start off with a data prep. So this is why I was emphasizing, do you know NumPy? Do you know Pandas? Because you cannot do machine learning. You cannot jump to building a model if you haven't done data prep, right? So it is a pipeline. So you'll see that the course has been structured that we start off with data prep. Then after data prep, we move on to building models and training models. Then we look at then deploying our models. We don't just jump into building models. Right? We have to start off with the first task in the pipeline, which is data prep. Right. So we can. So if you look at even deep learning, it's exactly the same, right? So we'll talk about deep learning. What's the difference between machine learning and deep learning and artificial intelligence, and so. But if you look at data, whether it's coming from streams or it's coming from a data lake. Right, you still need data preparation and analysis through what we call EDA, exploratory data analysis, and this is where you use the Jupyter Notebook, right? So this is where the Jupyter Notebook comes in, and then you've got now frameworks to be able to build your models like TensorFlow and PyTorch and so on, and then. But after you build your models, then you do what is called model serving. So model serving is another word for deploying of models. Are there any questions so far?
Not yet.
We are good.
All right. So let's talk about the machine learning ecosystem. So machine learning ecosystem is built around various tools. This is why you guys are learning how to learn Python, right? R, I don't use. Personally, I don't use R. Not that there's anything wrong with R, but the thing about R is not something that is used in production. Right? No one uses R in production. That's a fact, right? Because there are challenges with R that we'll talk about today, because R is what we call a single-threaded application. It's got limitations in terms of the amount of data that it can analyze, right? So R has got major restrictions in terms of the capacity of it to handle the one aspect of the V's of data, the volume, right? It's a major restriction. So R is not used in product. If you are doing a PhD thesis and an MSc thesis, and you just want to show that you know how to analyze data and you want to impress your supervisors, you use R. But after that, it's pointless because you're not going to use it in a production environment like at work, right? So I don't. Even though I know R, I've been using R for 25 years. I don't use R at all in terms of production environments. It was mainly meant for analytics. Yeah. So in 2014, when I was teaching analytics at Said Business School at Oxford, we used R because really Python was still in its infancy stages and no one was really talking about Python then, right? Yeah. But SQL is used when you, but of course you're storing data somewhere and you need to be able to analyze that data. So SQL is used a lot in terms of the scripting for extracting data from a databases. And then obviously Jupyter Notebooks. Jupyter Notebooks are very, very valuable because with Jupyter Notebooks, the reason why Jupyter Notebooks were created, we'll talk about the what we call reproducibility, right? What we call reproducibility. We'll get into that. And then there's TensorFlow. Most of you might know that have heard of TensorFlow. So TensorFlow is the machine learning tool that we'll be using for our data analytics and machine learning and deep learning. Right. So if you look at the tools that we're going to go, so it's mainly these top 4 which are used internationally. So we'll do Python, we'll do Jupyter Notebooks, we'll do TensorFlow, right? So the rest at this stage are not important because machine learning mainly is done through Python with Jupyter Notebooks using TensorFlow. Any questions on this?
No, sir.
Yes. Yes, guys. No question. So let me move on to the next slide. Yes. So the reason why we don't use R, so R is in production, right? Remember I said in production, not for academic, not for academia, right? In production. When I say in production, what do I mean? I mean at a work environment, right? Yeah, do you get it? Yeah, at a work environment where you actually have multiple groups of people who need to look at the data and so on. So R is really used in production environments. It's mainly for academia. Yeah, because of the limit. So R has got limitations. So with R it's difficult to analyze data bigger than 1 gig. Just a small data. 1 gig is small data, right? But other tools allow you to analyze vast quantities of data. It could be, we're talking of exabytes to petabytes to zettabytes, right? Of data. Right. So let's talk about analytics maturity. So analytics maturity looks at the type of analytics and the value that you derive from that particular type of analytics. Right. So the first is descriptive analytics. So the descriptive analytics looks at what happened, right? So this is your usual ad hoc reports, right, which you do at your company from structured data, looking at historical things that have happened within that particular company, and then you are reporting on aspects of the performance of that company, looking at that data. So that's descriptive analytics. It looks at what happened. Then you've got diagnostic analytics. Diagnostic analytics looks at when did it happen. So diagnostic analytics is equivalent to your audit reports. So with your audit reports, you close off a particular financial period, and then you then do reporting on that previous financial period, right? So that's your diagnostic analytics, right? So diagnostic analytics takes into incorporates descriptive analytics, right? And it looks at it is based on what we call hindsight. By hindsight, we mean things that have happened in the past or historical data, right? So this is why in terms of financing and accounting, there's no such thing as a real-time balance sheet or real-time financial statement. You have to close off a particular financial period and then you report on it. So everything that has happened in the past, right? So it's hindsight, it's looking at things that have happened in the past, right? It's looking at historical data. So if you can think of it like you with the analogy of a car, you're driving a car, everything that you see in the rear view mirror is hindsight. Everything that you see behind you that you've passed, right, is hindsight, right? So I would tell you that 90%, I would say 99% of the companies in Zimbabwe, right, they are using hindsight. So it's purely based on descriptive and diagnostic analytics, right? That's 99% of the companies in Zimbabwe. 99% of the companies in Zimbabwe is descriptive, diagnostic. It doesn't matter which company. They might look advanced, on the outside, on the exterior, but when you go inside, then you realize that they aren't doing much, right? In terms of analytics. Then the next level is what we call discovery analytics. So discovery analytics looks at why is it happening. So discovery analytics, giving the analogy of the driving of a car, is everything that you're seeing in the front of you, immediately in front of you, right? So this is got to do with the real-time analytics, real-time. So for example, if we look at exchange rates, right? You want to be able to look at exchange rates in real time, because exchange rates change every single a minute, a second, and so on. If you look at stock exchange data, right, what we call ticker data, right, it changes every tick. It changes every 1 millionth of a millisecond, right, in most stock markets. Right? So that's discovery, and it's things that are happening in real time. Then after discovery analytics, then you've got predictive analytics. So predictive analytics is forecasting, right? Is what will happen next, is everything that you're seeing far ahead in front of you, right? That's predictive analytics, right? So predictive analytics and discovery analytics are what we then call insight, right? So there's hindsight and then there's insight. Then the next level after that is prescriptive analytics. Prescriptive analytics looks at how will it happen, right? How will it happen, right? Prescriptive analytics looks at how will it happen. And then after prescriptive analytics, then there is what we call cognitive analytics. So cognitive analytics looks at what can't we see happening, right? So cognitive analytics looks at what can't we see happening. So prescriptive analytics and cognitive analytics are what we call foresight, right? So we've got hindsight, insight, and foresight. So if we look at it from another perspective, right? So hindsight, which is descriptive and diagnostic analytics, looks at what we know we already know, right? Yeah? Hindsight, which is descriptive and diagnostic, looks at what we know, right? Right, and then insight, which is discovery and predictive analytics, looks at what we know we don't know, right? Looks at what we know we don't know, right? And then foresight, which is prescriptive and cognitive analytics, looks at what we don't know we don't know. Looks at what we don't know we don't know, right? Right? So now, so there's a difference between hindsight, insight, and foresight. A majority of the Zimbabwean companies, they are on hindsight, which is descriptive and diagnostic. I haven't met a Zimbabwean company yet which is doing prescriptive and cognitive analytics. Not yet, right? Maybe we've got one or two that are doing some discovery and predictive analytics. Maybe one or two, right? Maybe one or two, right? But majority are stuck on audit reports, right? I was talking about these auditors. Is there any question on this? Come on, guys, is there any question on this? Or can you still hear me?
Yeah, we can hear you, sir.
Yes, we can hear you, Doc.
Okay. So we spoke about structured data, semi-structured, and unstructured data. That you take that, for example, looking at prescriptive analytics, you take structured data, semi-structured data, and unstructured data. You then use that to build a model. Then that particular model that you do, right, will look at what will happen, when will it happen, why it will happen, and how it will happen, right? So that's prescriptive analytics, just to go into more detail, right? And if we just look at a different perspective of it, if we're looking at prescriptive analytics, so we take into consideration what will happen, when will it happen, why will it happen, right? So that's the predictive analytics aspect of it. Then we look at the effect of the decision part of it to say, how do we benefit from this prediction, right? Well, how do we benefit from this particular KPI that we've forecasted, right? And then how would these decisions impact everything else? How does it impact everything else? So when you're talking of prescriptive analytics, we look at the predictions, the decisions, and the effects. Predictions, decisions, and effects. So that's what prescriptive analytics is, right? You look at the predictions, the decisions, and the effects. Is there anyone who's done prescriptive analytics in this group? All right. All right. Thank you. So if we look now at the different types of machine learning algorithms that are out there, you know, there's Bayesian, there's decision trees. Yeah. So this is why I was wondering, why is that on your question paper there's decision tree? Which type of decision tree? Right? Because you can have a classification regression tree, you can have an iterative dichotomizing decision tree, right? You can have a C4, C5, a chi-square, a decision stump, a conditional decision tree, and so on, right? Yeah, and then you've got dimensionality reduction, you've got instance-based machine learning, where you've got k-nearest neighbors and all the other different types of algorithms. You've got clustering, where you've got k-means and so on. You've got regression, you've got rule-based machine learning, you've got regularization, you've got deep learning and deep learning, you've got ensemble techniques, you've got neural networks. So this is a summary of all the machine learning algorithms, of which we will cover quite a significant amount of these. I'll say about 80% of these algorithms. So this is why I was wondering, why at this stage, you know, you're still doing programming and someone is talking about decision trees, yet you haven't done machine learning. Yeah. Anyway, so that this is just an introduction of what, when we're talking of data science, what do we actually mean, right? What are the composites of data science, right? Well, what are we going to do, right? What aspects of this data do we look at? What is data analytics maturity? What do we mean by that? Right? Are there any questions on this?
Yes, on the machine learning, the different algorithms which you said. So you mentioned that you'll be using maybe Python, Jupyter Notebook, and SQL, if I'm not mistaken. So does it mean for everything we're just using those three tools?
So we'll be using mainly Jupyter Notebooks and the Python and Jupyter Notebooks. Right? By Python and Jupyter Notebooks, we mean that there's NumPy, there's Pandas, and so on within that Jupyter Notebook. Right? There's visualization using Matplotlib, Seaborn, and so on. Right?
Okay.
Yeah. So in terms of SQL, we might do some aspects of SQL. In terms of, but not that much, because you're going to cover that when you do data more when you do databases. Did you do databases?
Yes, we did.
Yeah, so you should have covered a SQL in greater detail. So the focus is actually on machine learning algorithms and the use of them to analyze data, more than, you know, looking at the actual pairing of the data.
Okay, thank you.
I've got another question, sir.
Yes, go ahead, please.
Yes, from your vast knowledge in analytics and experience, maybe can you clarify to me the differences between deep learning and neural networks? Or maybe from experience, what you have experienced so far.
So deep learning is built. You're using neural networks, right? Deep learning is built on neural networks. So deep learning and neural networks so the architecture of deep learning is built on neural networks. But when we say deep learning, or deep neural. So there's neural networks, and then there's what we call deep neural networks. So when we're talking of deep neural networks, it's got to do with the architecture of that neural network, right? So so there's what we call shallow networks and deep networks. So deep networks are composed of at least 2 layers of neural networks. And shallow networks are composed of 1 layer of neural networks. So that's the difference. The difference is got to do in the number of layers of the architectures, right? So deep means more than 2. Shallow means neural networks which are composed of 1 layer. Right. So we'll talk about that more when we do deep learning.
Okay.
Yeah. So mainly now we do an introduction to neural networks. I do not bother about Hopfield networks and yeah, but we will of course we will do and radio basis functions networks. So what we'll focus on is actually deep learning, because in deep learning we do cover the theoretical aspects of neural networks, because you have to compose your deep networks using neural networks anyway. So we'll then talk about the Boltzmann machine, deep belief networks, convolutional neural networks, recurrent neural networks, and so on and so on and so on. Because they've got different use cases for various aspects of the types of machine learning, right? When you talk about supervised machine learning and unsupervised machine learning.
Okay, thank you so much.
Right. Are there any other questions?
Yes, sir.
Yes, please go ahead.
I just wanted to find out, I've been involved in this issue of data analysis. You said you start with the data preparation, but just before that, I do have challenges in my working environment in terms of the issue of data extraction. Where do we really get this data which we are going to start preparing?
Well, the data could come from some type of source, right? It could be Excel spreadsheet, it could be from an ERP system, it could be from over the web, and so on, right? So it could be from some source that you have existing within your company.
Okay. I think that's fine. Where I have a problem is on the issue of if it's an ERP system,
yes.
How do we extract that data to say, now this is all the data of the company, now I can start analyzing it?
Yeah, so normally if you've got an ERP, right, that ERP, whether it's Navision or SAP or Oracle or whatever it is using some form of database, right, where it stores that data, right? So therefore, you then go into the database to then use an ETL tool to extract the data, to transform it, and then to load it into your model.
That's fine, sir. Thank you.
What can I share? What can I share? What can I share? things. That I will. So what I'm going to do is I'm going to create a Google Classroom, right? So Evelyn, so what I'm going to do now is I'm going to create a Google and then within that Google Classroom, I expect you to add everyone, right? Is that okay, Evelyn? You add everyone onto that Google Classroom. So then I'll share all the materials, all right, all the notes that we'll be doing. So then I expect you then to upload, for example, the upload the recordings and all of the different sessions that we have in that particular class, so that everyone has got access to it. Is that okay, Evelyn?
She has responded in the chat that
hi, Doc.
Yes.
I'm sorry, I was having challenges with my mic. I think I can do that. You can share the link with me, and then I share with my colleagues. The link for the Google Classroom.